Hello, I'm Thomas O'Rourke, and I'm a tutor sponsored by the Office of Student Success for TSDC's AC Circuits. The next component I would like to introduce to you are inductors. Inductors are coils of wire that create an electromagnetic field and hold a charge in their electromagnetic field. Similar to capacitors, but inductors will not hold a charge once the power is removed. They only store it for a brief moment. In this slide is a physical representation of an inductor, your coil of wires with electricity being run through it, because as we discussed earlier, conductors with current going through them will create their own magnetic fields. But when put in a coil, they strengthen their own and each other's magnetic field. As represented by these blue lines, it creates a strong magnetic field. This is the diagram symbol for inductors, represented by an L. The amount of electricity an inductor can hold is determined by its length, the area in between the coils, the material in between the coils, and the number of turns. Inductors' unit of measure are henries, represented by capital H. So the more henries, the more charge it can hold in its magnetic field. Here's an example of what an inductor can look like. Anything from a resistor-looking component on the left to a donut with coils around it in the center, and some where the inductor coils and all are completely hidden by enclosures. Like with our other components, we also study inductors in series and parallel, solve for missing variables, and predict outcome voltages. The next circuit we're going to look at are RL circuits. RL circuits also come in series and in parallel and combination of the two. Most inductors have a resistor in them from the start due to the fact that you do not want to put straight wire from one side of your power to the other, for an inductor is just a bunch of coiled wire. Later on, we combined our resistor, our inductor, and our capacitor into a single circuit. These circuits are very helpful, but they can help people create filters for different frequencies. So when you're tuning in on your car radio and you want a specific frequency, chances are there is an RLC circuit in your radio helping you get only the channel you want to listen to. In RLC circuits, we go over three types of filters: high pass, low pass, and band pass. These filters can also be used in your radio sound system to allow low frequencies which produce bass notes to go only into your bass speakers and not into your tweet speakers. Setting up the circuit differently allows you to cancel out the low frequencies so that only your high frequencies will go to your tweet speakers. Thank you for watching. This is Thomas O'Rourke, tutor for AC Circuits from TSDC, sponsored by the Office of Student Success.